Okay guys, welcome to your how-to guide to make your graph for your cooling it down lab. Uh, what you're looking at right now is some sample data. This sample data is just kind of to give you an idea of what you might see on your lab data sheets. In this column here, you want to find your temperature change. So in order to find the temperature change, you're going to want to take your final temperature from this column and subtract it from its initial temperature. And then you're going to get some numbers. Now these are perfect numbers. Your numbers might be different than what you see here on the screen, and that's okay. And what you need to do in order to find your temperature change average is you have to find the average of your numbers here. To do that, you're going to want to add these numbers together and then divide by the number of trials you did, which is 2. So in this case, these are our temperature readings. So this is the data that we're going to use to graph versus, in this case, the independent variable was the baking soda. Okay, so this is going to be on your x-axis, and this is going to be on your y-axis. So let's take a look at the graph. Ta-da! This is your graph. And the first thing you want to do when you're graphing is label your axes. You have your dependent variable, okay, and the dependent variable, remember, is what we were looking for to change. And so in this case, that's going to be our average temperature. So on our dependent variable here, we're going to write average temperature. Average temperature change. Now I'm going to abbreviate, which you could do the same. So that's average temp change. And of course, we have to have our units. So the units are going to go in parentheses. And our unit here was degrees Celsius. So that's what you have for your dependent variable. Now your independent variable down here depends on what you changed in the lab. So if you changed baking soda, the amount of baking soda you used in each round, you're going to write baking soda here. If you decided to change the amount of vinegar, then you would write vinegar and put milliliters in the parentheses for the unit. But in our sample data, ta-da, we have baking soda as our independent variable. So that's what we're going to write on our independent variable side. So here we're going to write baking soda. And of course we have to have our unit, so that's going to be in parentheses as grams. Okay, so we have our 2 axes labeled. Next thing we want to add is a title. So we have to add a title for our graph. Most graphs, typically their title is whatever the independent variable is versus their dependent variable. So in this case, our graph title is going to be baking soda versus average temperature change. That's quite a title. And that's it. So now the next step is to set your scale. You have to set your scale for your y-axis and your x-axis. So to do that, you have to look at your data. Okay? So we're going to start with our y-axis. Our y-axis, if you remember, is your average temperature change. So for that, you're going to want to look over here. Now we have a very small difference in these numbers. So in this case, when you're setting your scale, you always want to use this, go up by the same increment. So each line should represent a specific number, and you should go up by that number every time. So in this case, because we don't have a huge difference between our numbers, we're going to start with where we wanted our temperature change to be at, which was we wanted to see a drop in temperature by 5 degrees. So on our scale, we're going to start here at -5. Okay? And so depending on your data, you might have seen an increase or a decrease. So again, you might want to adjust your scale accordingly. But for now, we're going to start here at -5. And so the next number higher than that is going to be, we're going to go up by 1 in this case for our scale. So -4, -3, -2, -1, 0, and now we're going to go positive. So it's going to go 1, 2, and 3. Whoops. So that's our scale for our y-axis. So again, you might need to adjust it depending on your data. And so if you have any further questions, you can always ask. But based on our data that we're using in the sample here, that's kind of what we saw here. It really didn't change a whole lot. So we're only going to go up by an increment of 1. Now, in order to set our scale for our x-axis, we have to look again at our data. So over here, we see that baking soda is at 16 grams, and here it's at 20 and 23. So not a huge difference between these numbers. So we might want to use a slightly larger scale than 1, because if you look at your graph paper, you don't have a whole lot of squares to work with. So I would say in this case, it would be a good idea to go up by increments of 3. So we're going to start here at 3, then the next one's going to go up by 3, so 3 plus 3 is 6, then 9, and then 12, 15, 18, 21, 24, and 27. Okay, so now that we have our axes fully labeled, we have the name of the axes, we have the scale set, it's time to plot your points. But before you plot your points, in this case, we're going to want to draw a line at where we wanted our desired temperature change. So for now, I'm going to use a different color. This is purple. Hopefully it comes out purple. Or a pink highlighter. So we're going to draw a line straight across at -5. That is where we wanted our desired temperature drop. Okay. So that's just going to help you see where you should have had your data points, just in case your data didn't reflect that you got the temperature change. You can see where you should have been in terms of your baking soda, and we're going to talk about that here in a minute. But for now, that's our temperature drop. That's how much we wanted to see. So now we're going to plot our points, like I said. So looking at this sample data, we're going to start off with our first data point, which should be at 23 grams. And we should have seen a temperature drop, an average temperature drop of -3. So our plotting point is going to be 23 and -3. Okay, so this is our x-axis, 23, and -3 on the y. So over here, we're going to go up to 23. So it's kind of between these two numbers here. So you're going to go a little closer to the 24 to be at 23. And then you're going to go up to -3. And there's your data point. So that's for round 1. For round 2, we're looking at 20 grams of baking soda and a drop in temperature at -4. So again, here on your x-axis, you're going to want to be around here because that's closer to 20. And then you're going to go up to -4. It's approximately there. All right, so that's round 2. And finally, for round 3, yay, they got it, the -5 drop. So here we're at -5 and 16 grams of baking soda. So we're going to plot that on our graph. So here's 16 and -5. So you're going to be right around there. All right, so you have your data. Congratulations. The next thing you need to do is, and this is the final step, make your line of best fit. So for a line of best fit, you're going to want to use your handy dandy ruler. Okay, here is your ruler. You're going to want to align as many of your points on your line of best fit and connect to your x-axis. So you're going to want to grab as many of these points on your line as you can. They might not all touch, and that's okay. You're going to want to grab as many as you can. So connect your points using your straight edge, and there's your line of best fit. And you want to draw these little arrows on the ends to show that it can extend. Now, if your data was as good as this and you got the -5 drop, which is great, then you'll see that you hit your goal. But if your data did not reflect that, you could predict where you should have been. So if this data point was not on the -5 line and it was somewhere down here, or you didn't even touch down in this area at all, if you extend your line, you could have seen where your appropriate amount of baking soda would have been, okay, by making that connection to your x-axis. And that's about it. Hope this video was helpful.